This presentation is an overview of the Watershed of Trees Meaningful Watershed Education Experience, a MWEE to engage students at the intersection of forest, water, climate, and environmental stewardship. We'll talk first about what is a MWEE, and then what is this MWEE in Prince George's County Public Schools. Meaningful Watershed Education Experiences are a regional initiative with a commitment from the governors of all the states in the Chesapeake Bay watershed and facilitated by the Chesapeake Bay program. The goal is to provide a meaningful watershed education experience, or MWEE, to every student in the watershed before graduation from high school. This is an effort that is subsequently expanded nationwide. So what is a MWEE? The MWEE consists of 4 essential elements that support investigations of local environmental issues and lead to informed action and civic engagement. A MWEE is a learner-centered approach that emphasizes the role of students in actively constructing meaning from their learning experiences. And it includes time for reflection, allowing students to refocus on how their learning and experiences affect the driving question that initiated the investigation. The 4 essential elements are issue definition, outdoor field experiences, synthesis and conclusions, and a culminating action project. So, expanding on those 4 elements, a driving question allows students to address a locally relevant environmental issue. They'll need to acquire appropriate background knowledge. They then work both in class and in the field, making observations, collecting data, and conducting experiments. They should also talk to experts so that they can subsequently identify, explore, and implement solutions for action. For this MWEE, a watershed of trees, a project team was convened early in 2022 to set up a framework and write a funding proposal to the NOAA Bay Watershed Education Training Program. Through that process, the team has developed a defining question, a set of outdoor field experiments to be completed by all participants, and a CAPSTONE experience, the district-wide schoolyard data jam. So why do we specify these elements in a student-centered learning experience? We want to create a framework that's flexible and within which we're confident that students are going to achieve a successful outcome. What's the driving question? Within a human-dominated watershed, what is the impact of trees on water movement, water quality, the creation of microclimates, and how do these processes influence the quality of life for human communities within the watershed? And why do we center this project on trees? Lots of reasons. Trees are ubiquitous. They're at every school. Trees are actually incredibly powerful actors in ecosystems. They're a rich curricular element providing lots of supplemental opportunities, and they're an essential climate solution. Trees are an important element of the Prince George's County Climate Action Plan. We've also designed one field experience for all students to work on. Completing a common set of core observations serves 2 purposes. First, this ensures that students have relevant data to address the driving question, and it creates a common database shared between each school in the district, allowing county-wide investigation and comparisons. Here's what the field experiment looks like. Students at each school will work with their teachers to choose a pair of field sites, one sunny, one shaded. 4 times a year, students will make measurements of the same set of environmental parameters at each site: air temperature, relative humidity using a sling psychrometer, ground surface temperature using an infrared thermometer, a soil temperature profile using soil thermometers. And then not this year, but next year, we'll add soil moisture to the set of observations. Here are some examples of what this might look like. The top image is surface temperature measurements made in a neighborhood in Baltimore in August. You can see from the marked temperatures that shade cast by trees has a profound impact on the temperature of the land's surface. The bottom images show soil temperature measurements and soil temperature data. On the left is a 3-month record of soil temperature across the seasonal transition from summer to fall. Soil temperature is measured at 2 depths, at 1 inch, shown in blue, and at 15 inches, shown in red. What we see as the seasons change is that in the summer, the shallow soil is always warmer than the deeper soil, and that reverses as we go into fall, with the deep soil always warmer than the shallow soil. With these measurements, students are positioned to understand the important connections between sunlight, energy, temperature, and both human and natural communities. We'll dive into that in much more detail in an upcoming presentation. The outdoor field experience could include any number of additional investigations. For example, light measurements in sun and shade, surface temperature measurements in other locations. Students could identify the trees they're working with and measure tree diameter to do a carbon sequestration calculation. They could do direct measurement of leaf photosynthesis. They could look at variations in atmospheric carbon dioxide. If there's a body of water nearby, they could look at stream discharge or water quality. When we move to the analysis and synthesis of these data, as we alluded to a minute ago, this is where it gets really interesting. This idea of looking at the nexus of temperature, vegetation, water, and humans can point in so many directions. And I think as they make their initial measurements, some of the students, even before they leave their field site, may begin thinking about environmental justice issues. And these can be supported by bringing different types of data into the analysis. For example, looking at the spatial distribution of income or tree canopy in Prince George's County and thinking about their temperature data in that context. Students might also think about natural ecosystems and the movement of water or carbon. Here, for example, are data made available by the U.S. Geological Survey and the National Weather Service for the Anacostia River. On the graph on the left, the blue line is the average precipitation in each month of the year, while the purple line is the water flow of the river over the course of the year. You can see that there's a huge seasonal mismatch here. While the precipitation is highest in the summer, that's exactly when the stream flow is the lowest. How's that possible? The answer is that the vegetation in the watershed controls the movement of water. Trees intercept and transpire precipitation so it doesn't even get to the river. On the right are water chemistry data made available by the USGS over the course of 1 week. Here we see daily variation. On top, this is dissolved oxygen as it responds to the daily photosynthetic activity of plants in the water. On the bottom, data that I think are really interesting, this is the pH change over the course of a week, also showing how the carbon dioxide that increases and decreases as a consequence of photosynthesis is actually controlling the pH of the stream. These data together give us an additional picture of the power of plants to control the physical environment around them. In support of the handheld instruments that students will use, we're also going to install permanent environmental monitoring instruments at the Schmidt Outdoor Education Center. A prototype set of instruments was installed in August. This will allow everyone in the district to follow the changes in air temperature, sunlight, humidity, soil temperature, and soil moisture over the course of the year. These data will help the students put their own observations in context. The field experiments are designed to prepare students to successfully undertake a CAPSTONE action project. Shown here is a sample template for how students might turn their field data into a concrete action. They will need to focus on a topic of interest, recruit stakeholders. They'll probably want to look at the County Climate Action Plan to contextualize their project, and then pursue the resources that they need to implement it. Finally, we've created a forum for students to present their work to the community. The Schoolyard Data Jam is an activity originated by environmental educators in Luquillo, Puerto Rico, working with the USGS and University of Puerto Rico. It's structured like a science fair, but students are encouraged to incorporate non-traditional modes of communication, either in part or in the entirety of their presentation. For example, dance, seen here in the lower left, or poetry, music, children's literature, in order to bring diverse skills, diverse disciplines, and the strength of each student to the project. More information can be found on the project webpage and in the links in the description below.